Okay, so now we're going to fill in a table of values that's in standard form. So a lot of the times you can solve for y, but sometimes it's actually harder to solve for y than to just plug the x in and then solve for the y as a value. So I'm going to show you two different ways, and you decide if it's, like I said, if it's too hard to solve for y first and then just plug the x in, it may be easier to plug the x in and solve for each individual y. So I'm going to do it, I'll say option 1. Option 1 is substitute x each time. So when x equals 0, you get 2 times 0 plus y equals 4. So 2 times 0, 0 is that whole thing, and then you get y equals 4. And then you plot 0, 4. Then you do it again. X equals 1. So 2 times 1 plus y equals 4. So you get 2 plus y equals 4. And if I want to solve for y, I need to get rid of that 2. So then I subtract 2, and I get y equals 2. And then I plot 1, 2. Then I get x equals 2, sub it in. So 2 times 2 plus y equals 4. 4 plus y equals 4. Subtract 4, and we get y equals 0. So then I plot 2, 0. And you can see I did it right because it forms a line. If you get points that are like jagged everywhere, you know you did some kind of calculation wrong. So take your ruler, connect the dots, go all the way from one end to the other. All right, I'm going to show you option 2. I'll write it in a different color. Option 2 is to solve for y first. So 2x plus y equals 4, meaning I want to get it in the form y equals, so then I can just pretty much do it mental math after that. So subtract 2x. I get y equals minus 2x plus 4. So now that we have it in that form, all we have to do is plug my x values in, and you can pretty much do that in your head. For instance, if I sub in, I'm just going to show my work because, you know, this is a video. But you wouldn't even have to do at this point. You just sub the 0 in there. What do you get? Y equals negative 2 times 0 plus 4. That wipes away. You get 4, exactly what I got over here. Same with when x equals 1. I'm putting 1 in there. So then I get y equals negative 2 times 1 plus 4. Negative 2 plus 4 is 2. Exactly what I did over here. And then if x equals 2, y equals negative 2 times 2 plus 4 minus 4 plus 4 is 0. Exactly what I got over here. So it's up to you which way you want to do it. Like I said, sometimes you're pretty much forced to do one option over another. But this way you have two options in your back pocket that you can use. Okay, so the next one, again, I'm going to show you by solving for y first. So this is pretty much option 2. So x minus 2y equals 4. So then I subtract x. Negative 2y equals negative x plus 4. And then divide by negative 2 to both sides. What happens when I don't have a number in front of the x? It's an understood 1. So then I get negative 1 over negative 2, which simplifies to be 1/2 x. And then the 4 divided by the negative 2, a positive divided by negative is a negative 2. So this might be the case where this may not be the better way to do it, and you'll see in a second. If x is 0, we get y equals 1/2 times 0, subtract 2. That wipes that away, and I get minus 2. So no big deal. That seems fine. Here's where I'm saying it gets a little glitchy now. X equals 1. Y equals 1/2 times 1 minus 2. Now, what do you get when you multiply 1/2 times 1? Well, you get a half. And then you have to figure out what's a half minus 2, and then you have to go in your back pocket. Good thing we're doing lots of Khan Academy to refresh our memory on fractions. We've got to get a common denominator. Common denominator between 2 and 1 would be 2, so this would be 1/2. Subtract 4 over 2. 1 minus 4 is minus 3 over 2. And you might go, holy, that's not great. This is why the other option might have been better. If you're having trouble solving for y, or if you sub something in and you have trouble, it may be easier to sub that in directly. So watch when I do it this way. I get 1 minus 2y equals 4. Then I subtract 1. I get negative 2y equals 3. And then I divide by negative 2. And look at that. I get the same answer. But which one was easier to figure out? Probably the second way of doing it. So that's why I'm saying I'm giving you two options to do this. It's totally up to you which one. Just pick one that's easier for you. And again, if you plot these points and they're not in a line, then you know you did something wrong. Okay, so now I'm going to do when x is 2, x equals 2, y equals 1/2 times 2, subtract 2. And if you forgot how to do multiplication of fractions, this might be a little troublesome as well. But in this case, the 2's nicely can't cross-cancel, and I'm left with 1 subtract 2, which gives me negative 1. Okay, let's plot these. 0, negative 2. Well, the problem with improper fractions is, although we're not supposed to be using mixed numbers for algebra, negative 3 over 2 might be hard to actually graph. So you may want to make this as negative 1.5. How did I get that? I just went negative 3 divided by 2. So then if I get 1 and then negative 1.5, it's right there, and then 2, negative 1. And so you can see it's in a line, even though I have a messy point right there, that it's going in a line like that. So I'll just take my ruler, connect the dots. So note, the above two examples are graphs of oblique lines, which means they're slanted. They're not vertical, they're not horizontal, they're oblique. Some people like calling them diagonal, but I always refer to the diagonal as at a 45 degree. So oblique is the term for any line that's slanted or any line that's not vertical or horizontal. How can you tell if an equation will graph horizontal, vertical, or oblique without actually graphing it? Does anybody think they know? Well, if you think about when it was in the form x equals some number, what kind of line did that graph? Well, that graphed vertical. When it was in the form y equals some number, what kind of line did that graph? Well, that graphed horizontal. If it was in the form, you know, something x plus something y equals some number, or if it was y equals something x plus some number, those were cases when they had both x's and y's in the equation. That would give you the oblique or the slanted line. Okay, so now we have a couple word problems. It says the sum of two numbers is 5. Let x and y represent the two numbers. Create a table of values of 5. So just come up with any two numbers that add up to 5. And of course, everybody says right away 2 and 3. Oh, sure. 2 and 3 add up to 5. 3 and 2 also add up to 5. 1 and 4, 4 and 1, 0 and 5. I can go on and on. So now I'm going to plot this. So 2, 3, 3, 2, 1, 4, 4, 1, 0, 5. And as you can see, it graphs a line. So I'm going to take my ruler, connect the dots. Bada bing, bada boom. We're done. except it says write an equation that relates x and y. So sometimes you can write it in y equals something x plus something. But notice my table of values. They're not in any order at all. So you may want to do it directly from the words where it says the sum of the two numbers is 5. Well, the two numbers are x and y. So that means x plus y equals 5. Because that's what I'm doing essentially from my table of values is x plus y equals 5. 2 plus 3 is 5. 3 plus 2 is 5. 1 plus 4, yada, yada, yada. All right. Now, this next example, sometimes people have trouble with this, and it's because I'm giving you certain points that you have to get. When they give you certain points you have to get, it may be easier, instead of solving for y, to put it directly into the equation. So in the first case, they're saying x is 0. So if x is 0, sub it in. 3 times 0 minus 2y equals 6. So again, anything times 0 will wipe that whole thing away. So then I'm left with negative 2y equals 6. Divide by negative 2. I get y equals negative 3. So now I'm going to plot that. 0, negative 3. The second one gives me where y is 0. So if I were to do that one, I would get 3x minus 2 times 0 equals 6. Again, anything times 0 will wipe that away. So really, I'm just left with 3x equals 6. Divide by 3. I get x equals 2. So then I'm going to plot 2, 0. So there's my second point. Get my ruler. And I connect with my ruler. So it says, what do you notice about where the line crosses the x-axis? What about where it crosses the y-axis? So these are topics that we'll be taking in grade 10 next year. And where it crosses the x-axis, that's called your x-intercept. Okay? The x-intercept is, again, where it crosses the x-axis, but this is when y equals 0. Where it crosses the y-axis, that's called your y-intercept, and that's when x equals 0. So some knowledge to think about later.